When converting a microchip-controlled woodworking lathe from 110 volts to 220 volts on a US residential split-phase system, surge protection is crucial, especially since the machine lacks a neutral. Here are a few surge protection options. Firstly, consider using two ZeroSurge protectors. The idea of using two separate 110 volt ZeroSurge type protectors, one on each hot line, with a conductor provided from the neutral terminals of the protectors back to the neutral bus in the load center is viable. Install two 110 volt ZeroSurge protectors on each hot line. Connect the neutral terminals of the protectors together with a conductor. Extend this conductor to the neutral bus in the load center. This configuration effectively creates a virtual neutral by connecting the protector's neutral terminals to the actual neutral at the load center. Surge currents will then be diverted to this virtual neutral and safely dissipated. Secondly, consider a surge protector with a neutral terminal. Some surge protectors specifically designed for split-phase systems have a dedicated neutral terminal. These protectors typically require a higher voltage rating, such as 240 volts, and should be wired according to the manufacturer's instructions. Thirdly, investigate whole-house surge protection. Installing a whole-house surge protector at the main electrical panel provides protection for all appliances and electronics in the home, including the lathe. These devices can be more expensive but offer comprehensive protection. There are also important considerations to keep in mind. Choose surge protectors with a sufficient surge rating and current draw capacity for the lathe. Consider the manufacturer's warranty requirements and consult with an electrician if necessary. Ensure proper grounding and bonding for the lathe and the surge protectors. Regularly test the surge protectors to ensure they are functioning correctly. For recommended surge protectors, consider these options. ZeroSurge GS-110-2, a 110 volts 20 amps model, triplite isobar 4 outlet surge protector with neutral terminal model TL415AN, and GE whole house surge protector model GF42000 480. Remember that proper grounding and bonding are essential for effective surge protection. Consult the National Electrical Code, specifically Article 250, for detailed requirements on grounding and bonding. This ensures a lower impedance path for fault currents, which helps to prevent electrical shock hazards and minimizes the risk of damage to equipment. Surge protectors work by diverting excess voltage to ground, protecting sensitive electronic components from damage. In a split-phase system, the neutral conductor plays a critical role in this process. If the lathe lacks a neutral connection, it is important to create a virtual neutral or use a surge protector specifically designed for split-phase systems. When selecting a surge protector, pay attention to its surge current rating, which is the maximum current that the device can safely handle. The higher the surge current rating, the better the protection. Also, consider the clamping voltage, which is the voltage level at which the surge protector begins to divert excess current to ground. A lower clamping voltage provides better protection. Regular testing of surge protectors is important to ensure that they are functioning correctly. Many surge protectors have indicator lights or audible alarms that alert you to a problem. If you suspect that a surge protector is not working properly, replace it immediately. Choosing the right surge protection solution requires careful consideration of the specific application and the electrical system. If you are unsure about any aspect of surge protection, consult with a qualified electrician. They can assess your needs and recommend the best solution for your situation. Always follow the manufacturer's instructions when installing and using surge protectors. Improper installation or use can damage the device or create a safety hazard. In addition to surge protectors, consider using other measures to protect sensitive electronic equipment, such as voltage regulators and line conditioners. These devices can help to stabilize the voltage and filter out noise, which can further improve the reliability of the equipment. Finally, remember that surge protection is not a one-time investment. Surge protectors can degrade over time, especially after repeated surges. It is important to replace them periodically, typically every 2 to 5 years, to ensure continued protection. By taking these steps, you can protect your valuable woodworking lathe from the damaging effects of power surges. In selecting the appropriate surge protection, one must consider the let-through voltage of the device. Let-through voltage refers to the maximum voltage that the surge protector will allow to pass through to the protected equipment during a surge event. A lower let-through voltage indicates better protection, as it means less voltage reaches the sensitive electronics of the lathe. Verify that the surge protector's let-through voltage is compatible with the voltage tolerance of the lathe's electronic components. A surge protector with a let-through voltage that is too high may not provide adequate protection, potentially leading to damage. Examine the surge protector's mode of protection. Different surge protectors offer different modes of protection, such as line to neutral, line to ground, and neutral to ground. For optimal protection of a 220 volts lathe on a split-phase system, a surge protector that provides protection across all modes is recommended. This ensures that surges are effectively suppressed regardless of their origin or path. When dealing with sensitive electronics, it is advisable to use surge protectors that incorporate advanced features such as EMI/RFI filtering. Electromagnetic interference and radio frequency interference can disrupt the operation of electronic equipment, leading to malfunctions or damage. Surge protectors with EMI/RFI filtering help to mitigate these types of interference, providing cleaner power to the lathe. The joule rating of a surge protector is another important factor to consider. The joule rating indicates the amount of energy that the surge protector can absorb before it fails. A higher joule rating suggests that the surge protector is capable of handling larger and more frequent surges. Select a surge protector with a joule rating that is appropriate for the expected surge activity in the area. In regions prone to frequent lightning strikes or power grid fluctuations, a high joule rating is recommended. It is important to note that not all surge protectors are created equal. Some surge protectors offer only basic protection, while others incorporate advanced features and technologies. When dealing with inexpensive, microchip-controlled lathe, it is prudent to invest in a high-quality surge protector that provides comprehensive protection. Cheaper surge protectors may not offer adequate protection and could potentially fail during a surge event. Consider the response time of the surge protector. Response time refers to the time it takes for the surge protector to react to a surge event and begin diverting excess current to ground. A faster response time is generally desirable, as it means that the surge protector can clamp down on the surge more quickly, preventing damage to the protected equipment. Look for surge protectors with response times of less than 1 nanosecond. Review the warranty offered by the surge protector manufacturer. A comprehensive warranty indicates that the manufacturer has confidence in the quality and reliability of its product. Read the warranty terms and conditions carefully to understand the coverage and any limitations. Choose a surge protector from a reputable manufacturer that offers a solid warranty and provides good customer support. Surge protectors should be installed in accordance with all applicable electrical codes and regulations. In the United States, the National Electrical Code, or NEC, provides detailed requirements for surge protection devices. Ensure that the installation is performed by a qualified electrician who is familiar with the NEC requirements. Additionally, remember to periodically inspect surge protection devices to ensure they are functioning as expected. Look for any signs of damage, such as cracks or discoloration, and test the surge protector using a surge protector tester. Replace any surge protectors that show signs of wear or malfunction. When implementing surge protection, a layered approach is generally recommended. This involves using multiple surge protection devices at different points in the electrical system to provide comprehensive protection. For example, a whole house surge protector can be installed at the main electrical panel, while individual surge protectors can be used at the lathe and other sensitive electronic devices. This layered approach provides redundancy and ensures that surges are intercepted before they can reach the protected equipment. Also, consider the environmental conditions in which the surge protector will be used. Surge protectors are typically designed for indoor use in a climate-controlled environment. If the surge protector will be exposed to moisture, dust, or extreme temperatures, select a model that is specifically designed for those conditions. Some surge protectors are available in weatherproof enclosures for outdoor use. Always disconnect the lathe from the power source before performing any maintenance or repairs on the electrical system. This helps to prevent electrical shock hazards and ensures that the surge protector is not damaged during the work. If you are not comfortable working with electrical equipment, it is best to hire a qualified electrician to perform the work. Also, remember to keep the area around the lathe and the surge protector clean and free of clutter. This helps to prevent accidents and ensures that the equipment can be easily accessed for maintenance and repairs. Avoid using extension cords or power strips to connect the lathe to the power source, as these can reduce the effectiveness of the surge protection. It is best to plug the lathe directly into a wall outlet that is protected by a surge protector. In addition, document the surge protection system, including the types of surge protectors used, their locations, and their specifications. This documentation can be helpful for troubleshooting problems and for planning future upgrades to the system. Store the documentation in a safe and accessible location. Also, consider consulting with an electrical engineer to design and implement a surge protection system that is specifically tailored to the needs of the lathe and the electrical system. An electrical engineer can assess the risks and recommend the best surge protection solutions. Keep abreast of the latest developments in surge protection technology. New surge protection devices and technologies are constantly being developed, and it is important to stay informed about the latest advances in the field. This will help you to make informed decisions about surge protection and to ensure that your lathe is adequately protected. After installing surge protection, monitor the performance of the system. Watch for any signs of problems, such as tripped circuit breakers or unusual behavior of the lathe. If you suspect that there is a problem with the surge protection system, investigate it immediately. Taking proactive steps to protect your lathe from power surges can save you time, money, and frustration in the long run. By following the recommendations outlined in this guide, you can ensure that your lathe is adequately protected and that it will continue to operate reliably for years to come. Remember to consult with a qualified electrician or electrical engineer if you have any questions or concerns about surge protection. They can provide you with expert advice and assistance to help you protect your valuable equipment.